This is a continuation of lesson 7.3 on similar triangles. And so this problem says identify the similar triangles and then find each measure. So for this problem, we have vertical angles that are congruent. We also have the alternate interior angles that are congruent because of the parallel lines. Now notice that we are not going to be able to do a side angle side because let's see how the sides match up. So across from the single marked angle is the 60, and across from the single marked angle here is 30. And then the double marked angle is x, and the double marked angle is 38.6. So it kind of looks like side angle side, but the problem is we don't know what x is, so we can't use side angle side because we don't know if the 30 and x is proportional to the 60 and 38.6. Then we also have 23, but it's not, we don't have the side over here, so we also don't have enough to be able to do a side angle side with a different pair of angles. Okay, so we can say the triangles are similar using that the vertical angles are congruent, and really you don't have to use that part, but you do need to use that if parallel lines are cut by a transversal, then alternate interior angles are congruent. So you could just use the two pairs of alternate interior, but I went ahead and threw in the vertical angles also because you could do one of each. So the triangles, it says identify the similar triangles. So I'm going to say triangle BAC. I'm going from single to double to triple marked angles is similar to triangle BDE by angle-angle similarity. So those are the identifying the similar triangles. Now, we can say that the scale factor from the small one to the large one, the scale factor is 1 to 2 because it's 30 to 60, so it's a 1 to 2 scale factor. And so you can go ahead and plug that in rather than using 30 and 60. So 1 is to 2. Every side there compared to every side there is a 1 to 2 ratio, is equal to x over 38.6. And if you cross multiply, 2x is equal to 38.6. Divide by 2, x would be 19.3. Okay, for the next one, we have again a reflexive angle, well, not again, but we have a reflexive angle up here of f, but we also again have parallel lines, which means those two corresponding angles are congruent, and these two corresponding angles are congruent. So you could either use a reflexive angle, or you can just use if parallel lines cut by transversal, then corresponding angles are congruent. So notice that on this one, that will make triangle FRQ similar to triangle FNP by angle-angle similarity. Now notice on this one we have 30 on the small triangle matches with 40 on the large triangle, and 32 on the small triangle matches with 32 plus x on the big triangle. So those corresponding sides, it's a small triangle to big triangle is equal to small triangle to big triangle's corresponding sides. Or you could also do big to big, so you could do like 40 over 32 plus x equals small to small in the same order, 30 over 32. Okay, there's lots of different ways to do that. I went ahead and stuck with 30 over 40 because I can easily take out a 0 there and then cross multiply. 96 plus 3x is equal to 128. So 3x equals 32. X equals 32 over 3, or 10 and 1 2/3, or 10.6 repeating. Any of those are fine. Please just make sure you do not round the answers at all. So Don't make it 10.6. Make it 10.6 repeating if you're going to turn it into a decimal. Okay, and then the last one in this group, we have, since this angle here is reflexive, angle G is congruent to angle G. Sorry, my G looks like a 6. Angle G is congruent to angle G by reflexive property of congruence. And then because this one is congruent to this one and this one down here, those two little parts down there are congruent, when you add those up, the big parts here will match. So on this side, it's 39, and on this side, we don't know the length of it. Oh, actually we do. I take that back. This is also 39. So 26 and 13 and 29. Now, notice that the sides down here, 20 and the X are going to match. Let me first write down why the triangles are similar. So because both of those will be 26 to 39, obviously 26 to 39 is going to equal 26 to 39. So the sides are proportional and you have an included angle that's congruent. So triangle GHW would be similar to triangle GIU by angle-angle similarity. No, sorry, side-angle-side similarity. And then we'll have, to find the value of X, we'll do 26 is to 39 as 20 is to X. Now notice that I did in the small triangle, side to large triangle side equals small triangle's bottom to big triangle's bottom. Now you could also do, another option would be to stay inside of one triangle, so you could do, for example, 26 to 20 and then do 39 to X. Now notice that when you cross multiply here, you get the same thing. You get 26x equals 39 times 20 as you would on this one. So they're equivalent proportions as we talked about yesterday. Now I'm going to go ahead and simplify a little bit because 13 will come out of both of those. So this would be 2/3 equals 20 over x. Obviously you'd be multiplying by 10 on the top, so you have to multiply by 10 on the bottom, which means x is 30. Or you can cross multiply if you want. So you can say 2x equals 60, x equals 30. Okay, and then the last problem, the height of two vertical posts are 2 meters and 0.45 meters. So I'm going to draw two triangles. 2 meters is the big one. 0.45 meters is the short one. Okay, when the shorter post casts a shadow that is 0.85 meters long, what is the length of the longer post shadow to the nearest hundredth? Okay, now again, we've got that angle of elevation idea, making these angles congruent because again, the sun casts the shadow at the same time of day in the same location. The shadows will be proportional to the height of the object that's being projected onto the ground. So the triangles are similar by angle-angle similarity. So we can say 2 is to x as 0.45 is to 0.85. Now, just because I like to review kind of the algebra here, or the calculations here as we go, I'm going to multiply by 100 on the top and bottom. So 2 over x equals 45 over 85. And then I notice that those are both multiples of 5 on the right. So I'm going to take out a 5 and make it 9 over 17. And then when we cross multiply, we'll have 34 equals 9x. divide by 9, x will be 34 over 9. Now that's approximately 3.78. It's not exactly, it's approximately 3.78. That's a rounded answer. That's allowed because in the problem it said to round to the nearest hundredth. If it didn't say that, you should leave your answer as 34 over 9. Now let's go back to this again for a second. You could say rather than, and I should say meters, because this was a word problem, we should put the label on it also. Okay, so going back to the problem for a minute, you could have said the height on the big one compared to the height on the small one is equal to the shadow on the big one compared to the shadow on the small one, for example. If you cross multiply, you get the same thing. Or you could do shadow over height equals shadow over height. So there's lots of different ways to set up the proportions for these problems, but you just want to make sure you're consistent and accurate in setting it up. This is the end of the second part of the video on Lesson 7.3.